So now that we've gone through and we've looked at how to find z-scores given our raw data in our calculator and how to find probabilities also with technology, we're going to go through and just look at some applications with the normal distribution. So example 9 says, suppose that the distance of fly balls hit to the outfield in baseball is normally distributed with a mean of 250 feet and a standard deviation of 50 feet. Let x equal the distance in feet for a fly ball. How is x distributed? So it says, right, that it's normally distributed above. So x is going to be normally distributed. And then so we want to know what the mean is, right, 250. And the standard deviation is 50 feet. Okay. So that's how we would write if the distribution. Now it says, if one fly ball is randomly chosen from this distribution, what is the probability that it traveled fewer than 250 feet? Sketch the graph, shade the corresponding region, and find the probability. Okay. So it wants, right, less than 220 feet. So probability that x is less than 220 feet. Okay. So if I draw my curve, we know, right, that the mean is 250. 220, right, is below that. And you can label some of this, right? 250, we can subtract some, they're 300. So, or sorry, it's 50. So we'd have 200, we'd have 150 and 100, right? Because we're just subtracting the standard deviation of 50. If we go above, we'd have 300, 350, and 400. So it wants to know 220. So 220 is somewhere in here. And it wants less than that, right? So there's my curve. Since we're trying to find the z-score, we're trying to find the probability, right? We don't really need to find the z-score since our calculator can just use that with technology. We can use our normal CDF. The upper limit, the lower limit is going to be, right, it's going to negative infinity. So negative 99,999. My upper limit is the 200, and my mean in this case, since we haven't converted it to the standard normal, we're going to use the 250 and the standard deviation of 50. Okay, so we'll hit our second, we'll hit vars to get our distribution. We're going to arrow down to normal CDF and hit enter. The calculator has it sort of defaulted. If you want, you can leave it, or you can just type over it. Our upper is going to be 2, and I noticed I wrote 200. It should be 220, right? That's the number we're looking at. So let me just erase that quick and change that. So it should say the 220, since that's the value that we're looking at, 220. My mean in this case now is 250 because I have not converted it to a z-score, and my standard deviation is 50. We'll paste that. And so we find that the probability, right, or the area, is going to be roughly 0.274. Again, if it wanted it as a percentage, we can then just multiply 100, right, and find 27%, 27.4%. Question says, find the 80th percentile of the distribution of fly balls. Sketch a graph and interpret the meaning of your answer. So we're going to try to find an x value here. So 80th percentile, right, so if I were to graph this, right, so I'll draw my normal curve, standard normal curve. All right, 80th percentile, it's more than half the curve, so something along these lines, right? And so we're going to use our inverse norm function. So inverse norm. So the area to the left, right, because percentiles are area to the left, so 0.8. Now my mean, if I put 0 here for the standard normal curve and 1, it's going to give me the z-score, which is not quite what I want in this case. I want the x value, right? We're trying to determine the distance, I believe, with this ball. So we want to actually put the true mean and standard deviation, the original data. So my mean is 250, my standard deviation is 50. Now if you have the newer version of the calculator, when it asks this, right, so 0.8, 250, 50, and then you're going to put to the left, right? So we'll hit our second, our distribution button, go down to inverse norm. Area is 0.8, My mean is now going to be 250. My standard deviation of 50. And then left. So paste that. So I end up with, right, x to be 292.08. And it says interpret the meeting. So we would say, so 80% of the fly balls go 292.08, right? Go basically less than this. So the 80th percentile, right, is 292.08. So they go up to this, okay?